We're going to continue on with talking about bonding with a discussion of covalent bonds, and we'll circle back to ionic bonds as well. And we still aren't going to be done with bond types because we still have hydrogen bonds to cover next. But anyway, stay tuned. This is covalent bonds. So covalent bond is any kind of bond that happens between two nonmetals. For instance, carbon and hydrogen. Okay, making, you might have guessed it, hydrocarbons. But you should know that covalent bonds are what happens between two nonmetals. So remember, the nonmetals are anything over here on the right-hand side of the periodic table. And hydrogen is a special case because it is on the left, but it is still a nonmetal. All right, so two nonmetals like carbon and hydrogen form a covalent bond. So in covalent bonds, these two species, carbon and hydrogen, are actually going to share an electron. Unlike in ionic bonding, where one just stole the electron away, in covalent bonding, they actually get together and they're peaceful and they share. This sharing is represented by this line. Okay, so carbon now feels like it has both of the electrons. So it has 1, 2, 3, 4, 5, and hydrogen feels like it has 2 electrons. So who is happy here? Carbon's not happy. It has 5 electrons, right? It's trying to get to 8. Hydrogen is actually happy here because it has 2 electrons. And it's kind of funky, but hydrogen now feels like its outermost shell has been filled, because remember that first shell of electrons can hold 2. And so hydrogen is happy. Carbon is still not happy yet, though. So what do we need to do? We need to add more hydrogen. And so now carbon feels like it has both of these electrons. Remember, there's 2 electrons in this line. There's also 2 electrons in this line. So carbon feels like it has 1, 2, 3, 4, 5, 6. So carbon's not happy yet. It wants to have a filled outermost shell. So let's add some more hydrogen. Carbon now has 1, 2, 3, 4, 5, 6, 7. We'll add our last hydrogen here. And now carbon feels like it has the full outermost shell. This is CH4 or methane. Carbon is now stoked. It's got a full shell. These hydrogens are all happy. They have a full shell. So life is good. If you ever see a carbon atom with 5 bonds, something has gone terribly wrong. And so I won't get mad at you, but if you wind up taking organic chemistry, your organic chemistry teacher will for sure get mad at you for making something with 5 bonds. And how do we know something has gone terribly wrong? So let's add our 5th bond. So we now have 1, 2, 3, 4, 5 bonds here. How many electrons does carbon now have? Well, it has 2, 4, 6, 8. It feels like it has 10. Okay, so carbon, not particularly happy. It wants to have a filled outermost shell, and now it has even more electrons than it knows what to do with. And you won't see this in nature. You will not see CH5. CH4 all the time, carbon with 4 bonds, always happening throughout nature. You will not see a carbon with 5 bonds because that's too many electrons. It's violating the octet rule. So let's do another covalent. So O2, oxygen is a nonmetal according to this periodic table, and if we have 2 oxygens, then obviously that's going to be a covalent bond. They're going to, again, share those electrons. In covalent bonds, they share. So we've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and that should make sense to you. It's in the 6th group over here. So oxygen should have 6 valence electrons. And so what it's going to do, it's going to share, this oxygen on the left is going to share these 2 electrons, and this oxygen on the right is going to share these 2 electrons that are going to be represented with these lines. Okay, so this top line represents 2 electrons. This bottom line represents 2 electrons. And each of these oxygens, since they're sharing them, feels like it has those electrons. So it has 1, 2, the one on the right has 1, 2, 3, 4, 5, 6, 7, 8 electrons that it feels like it has. So this one is happy. It's got a full outer shell. The one on the left here has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So the one on the left also happy. Both of these filled outer shells, and this is why you see diatomic oxygen. This is why you see O2 in nature quite frequently. So there you go. Full outer shells because they're covalently sharing these electrons. So let's look at CaCl2. So what kind of bond is CaCl2 going to be? Well, if we find calcium over here, we will see that it is a metal. If we find chlorine over here, we will see it's a nonmetal. So that's a question for you, and a question you could get on an exam is, what kind of bond is calcium carbonate? CaCl2? Well, it's ionic, right? It's a metal, calcium, and a nonmetal, chlorine. And I said carbonate, I meant calcium chloride, sorry. So now we know it's going to be ionic. How many valence electrons does each of these have? Calcium has got 2 valence electrons because it's in the second group. Chlorine has got 7 because it is in the 7th group. So here are our 2 elemental species, calcium with its 2 valence electrons, chlorine with its 7. And this is, by the way, this is like the coolest thing ever, that you can predict what these chemicals are actually going to physically look like just by kind of taking a peek at the periodic table. So, but let's look at the chemistry of it. Let's see what's actually going to happen here. So calcium's got 2. It doesn't want those 2. It wants to have a filled outermost shell. Chlorine's got 7. It wants to get 1 extra. So let's see what's going to happen chemically. So calcium's going to get rid of this 1 electron. It's going to give it up to chlorine. And calcium's going to become slightly positive. Chlorine's going to become slightly negative because, again, chlorine grabbed that negatively charged electron. Calcium lost that negatively charged electron. So you can see here calcium is still not happy, right? It still has an incomplete outer shell. It has just that 1 electron now. Chlorine's now fine. It's got a filled outermost shell. It has this negative charge, not that big of a deal. But so what's calcium going to do? Well, calcium is going to find another chlorine atom, and it's going to give away its last electron. So it will have a filled outermost shell, and those are all going to get together to neutralize their charges, and you wind up with CaCl2, which could be written like this. No one writes it like this. Everybody writes it CaCl2 instead of putting 2 Cl's up here. Okay, and so you remember these are your reactants, Ca and 2 chlorines, calcium and 2 chlorines, your chemical reaction arrow here, and those are going to yield your products, CaCl2. So you should kind of know ionic versus covalent bonds. Why do these different bonds form? It's so that they can have filled octet rules, or the filled outermost shells. Okay, you should know that an ionic bond is between a metal, something on the left end of the periodic table, and a non-metal, something on the right end of the periodic table. And you should know a covalent bond is between 2 non-metals. And covalent bonds, they're going to be sharing the electron.